Hi, and welcome to a project which I've just finished to create a touch-sensitive input keyboard for use with Sonic Pi. You can see the keyboard structure in the video in the top section essentially of my screen here, and underneath it there is a terminal window which is going to enable me to start a program running on the Pi Zero, which is underneath the board here. Plugged into that is a Raspbian Pro Hat made by Alex Eames, and that incorporates a small breadboard on it, and into that breadboard is plugged a small card from Adafruit, an MPR 121, which is a 12 capacitive input board which runs via an I2C connection onto the Pi Zero. And by using a Python library which they supply, it's possible to extract information about which of the touch-sensitive inputs have been triggered. I have taken this excellent tutorial which they produced to get this up and running, and I have added to it support for OSC messaging using the Python OSC library. And this enables me to use the Pi Zero to send external OSC messages, which can be picked up by my Mac, which is running Sonic Pi 3.1. It will equally, by the way, work into a Pi 3, and in fact you can plug the Raspbian Hat there into a Pi 3 and use Sonic Pi on the same machine. But I prefer to keep things separate because sometimes I want to use a Pi, sometimes I want to use a Mac, and so I decided to base this on the Pi Zero. It's also cheaper to do that, assuming you've got something else which can already play Sonic Pi. For my keyboard, I've used a large breadboard, and the 12 jump leads which are plugged in along here are connected to the end connectors on the Adafruit board via the small breadboard there. And for the keys, I've simply used a little jumper in line with each of these, which you can touch, and these will cause triggering. You've seen it's lit a red light there. It's not actually, in fact you probably can't see it, just move it slightly, there we are. You could see the red light there which is lit. It's not gone out because I've not actually got the program running there. But having said that, let's come down here and we'll start this running here by simply pressing the Enter key. And in a minute you'll see on the main screen, there we are, Adafruit MPR 121 capacitive touch keypads, press Ctrl C to quit. And that is now live. We haven't actually got Sonic Pi running yet, but if I touch one of the keys, you can see the OSC messages that it's sending /key2 there because I pressed the second key. And on the bottom right of the screen, you can see that Sonic Pi has picked up /OSC key2's messages, one with a 1 against it and the other with a 0 against it. If I move the keyboard cursor down there and just indicate the region that I'm talking about down there, and these match these two OSC messages which are sent. Notice Sonic Pi puts a /OSC at the beginning of any OSC message it receives. This is just to indicate the source that it's an OSC message, because you can get other cues coming in from, say, MIDI or from internal cues generated in Sonic Pi. So enough of the blurb, let's actually get it going. To do that, I'm just going to take this simple program which I've got in Sonic Pi here, and this is simply essentially running on a live loop which is going to respond to messages coming in addressed to /OSC/key star. The star is a wildcard, and by using a little function which I've written up here, it's possible once this has been triggered to decode the address which has actually caused the cue, and from that to extract the key number which was pressed. And then I've simply got a series of if statements to say if the key number is less than 8, in other words it's keys 0 to 7, then it's going to play a note and it's going to offset this by 0, 2, 4, 5, 6, 7, 9, 10, 11 or 12, which will be the notes of a scale starting from a bass note here. The bass note in turn can be altered by the next two keys to either go up or down, and so we can change the range of the octave which is being played. And the last two keys, keys 10 and 11, I've used to select the synth, either the pluck synth or the piano synth, which is being used. So if I click on this to play it, it'll bring Sonic Pi to the front. So we'll start that running, and we'll just bring the other two screens back as an overlay on top so you can see what's happening. Three things you can watch. You can watch the video of the keyboard and see my fingers pressing the keys. You can watch the terminal screen underneath, which signifies the messages which are being sent. And you can watch that's down here, and you can watch the OSC messages coming in here as cues to Sonic Pi, and of course you'll hear the sounds that it produces. One final gotcha to warn you of if you try and do this: if you're sending OSC messages externally into Sonic Pi, you must make sure that you enable it to receive remote OSC messages. This is obviously a slight security issue, so by having that turned off, it keeps Sonic Pi secure. When you turn that on, it will respond to OSC messages being received on port 4559. So we've got the program running, we're ready to go. Let me press a key and see what happens. There we are. You can see that that's playing. Each time I tap the key, you can hear it, you can see the cues, and you can see the red light hopefully flashing. Doesn't come out very well because there's a bit of a lag on the video, but you can see it occasionally flashing there. And we've got the scale. We can even play chords. And if I use this, I can go up an octave, or down an octave rather. Up an octave. And I can change to use a piano synth. Let's come down an octave and play a well-known tune. So that's the first program that I've got here, but I'd previously done some work using a PS3 wireless controller, which I have here, and you'll have noticed, the eagle-eyed among you, that there is actually a dongle on the end of the lead here. That's not a wireless dongle, because I'm actually using a Pi Zero W, which automatically has built-in Wi-Fi. But it is so that I can talk to the PS3 controller here, and I've incorporated that into a different version of the software which is running on there. If I stop the first version here by stopping this, put a Control C in there, we can change the program that I'm running. Instead of using OSC key, I'm using OSC key PS3. And that has got built-in support. I've only added limited support for this particular program, though in principle you could have all of the keys on the controller here available. But I just wanted to use one of the joysticks here to allow me to adjust the cutoff value of a note and the volume of some notes by using these two different axes. So that's the only one which is going to be activated in this program. And if I now run that, there we are. And if I take the PS3 controller and I move it sideways, you can see that it's giving some extra commands in here there's a command /RUD, that's the address it's sending, and that's my shorthand for right-hand joystick up down, and it's giving RLR, which is right-hand joystick left and right. And you can see that these each range between -1 and +1. This one's actually the other way round, but that's taken care of in the program. And here we've got the up-down one. So let's just switch to a slightly different Sonic Pi program. It's in buffer 1, which I'll change to there. It's a slightly more involved program, and it's actually based on one which I published fairly recently called Sonic Pi Loop Controller, which was originally controlled by a TouchOS C screen, but here I've modified it so that it will run on the touch keyboard we have here and on that single input from the PS3 controller. So we'll start that running, and we'll now bring the two other screens back into view so we can see what's going on. Oops, gone too far. That one. There we are. And we're now ready, and the first key is going to act as a toggle to put on a repeating metronome beat. Oops, one thing I didn't do is actually running the other program as well. So let's just come back to Sonic Pi and stop that, and we'll run this program. We'll bring those two back into view again, that one and that one, and we'll try again. There, that turns on the beat, and each one of these other ones controls one of the loop percussion samples which are built into Sonic Pi, and it'll stop as soon as you lift this. It'll start again from the beginning when you press your finger down. This one gives a continuous cone that beats against the first one, and the next one is slightly different. It gives a range of repeating notes using the TB303 synth. And this is where this comes in, because I can change the cut-off, and I can change the volume of it. Make it quieter or louder. Video of that screen, but you get the idea of what's actually happening. And if I actually push and release the joystick, I've programmed a dead zone in the middle so I can very quickly set it to maximum and then just release it like that. Then we get on to some further samples. Leave the last one till the end, and we can then start grooving away with this with different patterns. So some different uses for this. We'll just slowly fade out the percussion. Then we'll play the last sample.
Thank you for pushing the button to play me. Thank you for pushing the button to play me.
And that completes the demonstration, but I hope you'll agree that it makes a very nice addition to Sonic Pi, just having some mechanical inputs which you can use just like a keyboard, and it produces quite a nice overall effect. Thank you very much for watching the video, and this will all be published in an associated article with a link below the video where you can pick it up with the links to all the software as well.